So this is going to be a pretty short video, and yes, did I make a video that's short just so that we can have range be the punchline of a previous video? I don't know. Anyway, let's talk about what range is and what the word onto means. Now, you've probably heard the word onto before, but maybe not like this. So let's get into it. We'll start with the definition, and this is going to be a fun definition because this definition uses important stuff from chapter 1. So the image of the domain. All right, we'll start with there. What was image again? The image of a set is all the outputs. I'm going to go back real quick to where I introduced the definition of image. And I want to, if I can find it, I want to visualize this. I think this is actually really good. Let's say that we have a domain that's this red set and a codomain that's this blue set. And let's look at some kind of subset. Let's call this subset A. It's a subset of the domain. Then if we take everything in A, right, apply F to it, the image is just whatever those all go to. This is the image of A. So that's everything. It's like the set of all the outputs for that subset. That's what the image is really doing. Okay. The image of A is all the outputs. It's the set of all the outputs that come from all the inputs of A. So the image of your domain is not necessarily your codomain. The image of your domain means the set of all the outputs that you actually get from your domain. And that is what is called the range. The range is the image of your domain. And that is always a subset of the codomain. But sometimes they're equal and sometimes they're proper subsets. Okay? So if the range equals the codomain, we have something very special. Okay? We say that F is onto, and a very important word that is not included in this textbook is we say F is surjective. Not subjective, that's very different. F is not subjective because F is a function, and functions are actually very much not subjective. They're very much objective. Let's use math words again. Surjective and onto mean the same thing. These mean exactly the same thing. Not like mostly the same thing, they mean exactly the same thing. Onto and surjective, we'll use them interchangeably. The book uses onto, but you should also know what the word surjective means. I'll try to use both. Okay, so let's just have an example, and then that's this video. Hopefully it should be nice and easy. So I want you to find the domain. I want you to find the codomain and the range for f of x equals the rounding function, the nearest integer function. So I don't know if you've seen this before, right? But the nearest integer for 3.4 is 3. The nearest integer for 3.5 is 4. It's just you round to the nearest integer. Okay? So find the domain, the codomain, and the range. Once you've done that, I want you to say, answer, is F surjective? Is it onto? And then I want you to answer whether this statement is true or not. Is the image of the interval from 1 to 2 equal to the image of the interval from 1 to 2 exclusive? And this is really annoying thing about math, right? Brackets, square brackets can mean very different things. Square brackets of a number are going to mean the nearest integer. Square brackets around something like this refers to interval notation. This is all the real numbers between 1 and 2, including 1 and 2, right? Just like this could either mean an ordered pair or it could mean interval notation. And you have to just know based on context. You can always ask if it's not sure. But again, I just want to say this is interval notation here. So pause the video, try to answer all these, and we'll go through them together. So the domain, we can take in any real number. Okay? Any real number, we can find the nearest integer for it. What about the codomain? Codomain is the types of numbers this goes to. And actually, you could say a variety of codomains here. You could say R is the codomain. That would be fine. You could say Z is the codomain. You couldn't say N is the codomain, because there are negative things that we have to consider in the output. But yeah, you could use either one of these. The range only has one answer, though. The range is all the integers. And remember why it's possible to have multiple codomains in this. And again, usually when we define functions, we'll include the codomain in its definition. The next video is where we formally define a function. We've been kind of towing around it. The next section will formally define it. And yeah, we'll always say what the codomain is here, but we don't actually know in this example because I didn't tell you. Could be either one of these, depending on how we define that function. So is f surjective? Is it onto? And the answer is it depends. It depends on our codomain. Remember, surjective means if the range is the same thing as the codomain, then it's surjective. It's onto. Well, if this is the codomain, it's not surjective. If this is the codomain, it is surjective. So it kind of depends on your answer. So this could be yes or no, right? Depends on codomain. And again, usually there's not going to be multiple codomains. When you create your own function, you can have whatever codomain you want. But usually when I give a function, I'm going to give you the domain and I'll give you the codomain. You would still have to find the range though. All right, finally, letter C. Is that true? Well, let's look at those two things, right? The image of the interval from 1 to 2. What does this mean? Let's write this set down intentionally. This is going to be the set of all numbers y such that the nearest integer of x equals y, and x is in the interval from 1 to 2. So what is this image? We defined it intentionally, but we can also define this extensionally as well. It's a set of all outputs such that the input is in here. This is really the abstract definition of what image means. This right here is what image means. Right? In general, the image of some set A is this exact definition, where this is just A and this is F right here. So we really kind of have the arbitrary definition of image right here. But anyway, the answer is 1 and 2. Right? If you find the nearest integer to anything in this interval, yeah, it'll either be 1 or 2. So with that in mind, right, we also looked at this image. That's also going to be the set that contains 1 and 2. So yeah, that is true. So this does equal the image for the open interval from 1 to 2. So yeah, it is true. And that's how we can connect some of these concepts and topics from multiple sections and multiple chapters. Let me know if you have any questions, and have a good one.